That. I want to welcome everybody to, as Lori said, things you didn't know Inventor could do part two. It's funny, once I start down this track of it, some people call it Inventor tips and tricks and things like that. But whatever you call it, it's the result of me teaching Inventor classes and talking with students, and many students that come to these classes have taught themselves a good bit of Inventor. And whether they're brand new or whether they've been using it for years, they all at some point in time during the class will discover a feature that they didn't know was in there, that they didn't know could happen. Real quickly, again, as Lori said, my name is Rusty Belcher. I'm an application expert focusing on the manufacturing aspects of the product design manufacturing collection. Been working with IMAGINiT for a little over 22 years at this point, and all that time I've been focusing on the mechanical applications offered by Autodesk. We have a really a simple little agenda to go through. Today we're going to be looking at these tips and tricks and work techniques. We'll have a simple introduction. We'll look at some of these techniques are in sketching. Some of them have to do with the user interface. There are a couple of workflows in here I think you might not have seen before, but these are going to be modeling techniques, assembly techniques, drawing techniques, and even some rendering stuff if we can make that happen. As I said before, I teach Inventor quite a bit. This past week, it's been amazing. I've been teaching not just Inventor, but this week I taught the Navisworks class. It's a great class. But a couple of weeks ago, I taught the Inventor Basics class, and sure enough, while I'm teaching the class, a student looks up and goes, "I didn't know Inventor could do that." Or I was teaching a one-day class yesterday for a company that are for one of the air bases around here, came in just for a one-day refresher in Inventor drawings. And during that class, somebody said, how long has that feature been inside of Inventor? Or the worst one to hear is, man, if I had just known that feature was in there last week, I could have saved myself so much time and effort. So that's where this idea comes from. Before I jump into it, I hope you understand the importance of training. I can't go any further without bringing up the fact that IMAGINiT has a number of classes available. And it doesn't matter how long you have been using these applications, I can almost guarantee you if you take the training classes, you're going to find new and productive features that'll make your life as a designer much better. I mentioned my week to you. I've been working with Navisworks this week. Yesterday we were in Inventor drawings. A couple of weeks ago I was doing point cloud classes. We, as IMAGINiT, we can develop custom training based on your needs, and that point cloud class is a very good example of the shipyards in my area wanting specific laser scans, and not just how to scan. No, it's how to bring the scan into Inventor and use it and develop models from it. So I tried to keep our content today kind of grounded in some of the classwork that I do. But if you ever come to one of my classes, just in conversations with the instructor, you're going to find that, you know, we've been there, we've done some pretty crazy things, and we share war stories. And sure enough, some of the features in those war stories are what you guys need in your daily life. So let me see, I'm going to stay here first, and let me hop over to Inventor, and let me do my official welcome here. So the first thing we're going to look at is just an official welcome to the class. So I've got a file here with some text in it, and I'm going to extrude the text. So right off the bat, I hope you know you can extrude text from a sketch. So we'll do that. I'm going to share my sketch. Here's something you might not know. When you go to share a sketch, all you really have to do is make it visible. If you just make it visible, and then use it again. So if I were to just extrude this in the opposite direction, if you just use it again, Inventor will automatically share it for you. You just have to make the sketch visible, and then you can use it multiple times and it will become a shared sketch. All right, so I've got my text and I've got my blank plate. Let's flip that thing over and sketch on the back of it. We're going to use a really obscure command here just for fun. I'm going to bend this plate. I want to make sure that that line goes to that point, and we'll finish our sketch. I'm going to bend this. A bend is a tool that we don't hardly ever use. It's not a sheet metal tool, but it allows me to bend my part based on a bend line, and I can bend it both directions, and I can set my radius to, I think, 5.4 and my angle degree to 360. Click OK, so I can basically wrap that around. All right, so now if I sketch on my mid-plane there, I can project my geometry. If you were on our first Inventor didn't know, if you're on the first call with the things you didn't know Inventor could do, we talked about this one, about how with the line command you can draw an arc right in the middle of the line command and snap it there. So if you want to know more about that, you might want to check that link that Lori mentioned and go back and review that. But if I snap that there, let me just pull this over here. We'll revolve this. Just hit R for revolve. All right. And then to finish this up, just make it nice and pretty. Let's get rid of that plate. Let's sketch on the top of that plate. We'll project our geometry. And then I'll extrude. I just hit E for extrude. I'll just cut through everything. I'll click OK. So here we go. We've got bent circular text around the ball. And let's just make this pretty. We'll come down and find some flaked satin there, and there you go. So welcome officially to the things you didn't know Inventor could do part 2. So I hope you just learned some stuff just in that. These parts are kind of fun. Let me share with you some fun stuff with these parts. If I go over here and let me zoom in a little bit. If I go to my orbit, you know, I think everybody's found continuous orbit, I go to orbit there, so I can spin this and get it to go around by itself. And I'm in perspective view. You can make it look all kinds of cool and different visual effects that you can apply to the parts. So that's my official welcome to you guys. And that's what we're going to look at today. We're going to look at some work techniques that are kind of uncommon, and they're not so well known. But if you know them, man, you can make just short work of certain tasks. Let me share with you a story I mentioned before in my PowerPoint that I was teaching the other day. Yesterday, I was teaching a one-day Inventor refresher class for drawing creation. And in that class, we got to the center line command. So if you've ever done center lines in a drawing, you know how you can go to the annotate, and you can use the center line command and put the center line in, and a center mark and a bisector and all of that. So during the class, I mentioned that you can select a view, and Inventor also, if you hold the control button down, you can select multiple views. So I've got my 3 views selected. There's not much you can do with multiple views selected, except if you right click, you can go to automated center lines. If I select that, I get the automated center lines, and I can say I want a center line through every hole or a center mark. I want center lines for cylinders and revolves, for patterns, for the front and the side projections. And then here you go. If I click OK, all the center lines and all the views are added all at once. And I had a person in the class literally say, do you know how long I've been using this tool, and I've been dropping these center marks in one at a time, and you're telling me I can now do them all throughout the drawing all at once? I can even make that shorter. If in your template, if you go to Tools, Document Settings, under the Drawing tab, right here, there is a default automated centerline option. So you can go in and you can define what your default centerlines are so that you don't even have to click the buttons. So some really neat options. And I'm not joking. That's the core of what you guys are looking at today, is the things that pop up in my Inventor classes that they're not necessarily in the book, but it's stuff the instructor gets to show you. Let's see, I want to move on here. Let's see what we're going to look at next. I'm going to hop back over to PowerPoint for a minute. So the next tips I want to look at are for sectioning in an assembly or a part file. So I'm going to open up a part file, and it's not shameless self-promotion, but it is self-promotion in a way. I believe I'm scheduled to do another webinar. The next webinar I think I'm scheduled to do is for 3D annotation. And I happen to have this part up. I figured I'd include it. So be on the lookout for an upcoming webinar on 3D annotation if you're interested in that. But what I want to do here is I'm going to go to my View tab, and I'm going to use the section views for the part. So I'm going to do a 3/4 section view, and I'll set up my first plane as my XY plane. I'll click the continue. I'll set my next one up as my YZ plane. I'll finish that. And you can see my section view, and you might be looking at this and going, hey, where'd those hatch lines come from? Well, in Tools, Application Options, all right, and under Colors, in the modern versions of Inventor, I think 21, 22, 23, I believe, you have this section capping plane texture. And by default, Inventor has this default gray sandy color. I always think it looks like sand. But in the newer releases, you can use a bitmap image for that. And you can add whichever, it's just a bitmap. That's all it is, just a picture. I say bitmap, it's just a picture. I have several of them here. I spent some time in prepping for this. I went down a rabbit hole developing these repeating textures. And I'll tell you that it was actually quite difficult to make these things. I made some that have like the transparent background. So, you know, if I were to use those and apply, you'd see the orange color of the part and it would just overlay the lines on top of it. And then I made some, I think you can see, that have a material texture in there. And if I make that one and apply it, it has kind of a material texture in the background. And I made some black and some red. It took me, honestly, and it might be just my wee little brain, but it took me about 2 days to really figure out how those repeating textures are applied, and then how to, you know, make my individual little pictures that I can use on this. But this adds a lot of visual integrity to your parts. It's a nice little feature, and it works in assemblies as well. So I'm going to close this one. You've seen how that works. Let me open up a simple little assembly. This is a bottle jack. I've had this model for quite a while. I'm going to go to my View tab. I just like to turn on shadows there for this thing. And again, I'm going to go to my section views. I'm going to stick with the 3/4 section. And I'm going to start my first plane on my XY plane. Now, what I want to show you here real quick, I want you to notice that with multiple parts in an assembly, each part gets a different hatch pattern. It's the same texture, but it scales it up and down, and it adjusts the angle so that each part gets its own specific hatch, which is really nice. And if I go over here to the side, I'll just finish the section view there. There we go. It looks really good. While I was doing this, I thought to myself, there's got to be a way, this center screw, there's got to be a way for me to make the center screw avoid being in the section. So here's another one. Took me about an hour or so to find this. If you don't want your part to participate in the section, so I'm in an assembly, you double click the part, you activate the part, and then you go to Tools, Document Settings, and on the Modeling tab, you can click Participate in Assembly or Drawing Sections. You'll notice the check mark here. You can uncheck that. Click OK, and when you click Return to your main assembly, that part will not participate in the section view. I guess the one thing I found on this that just kind of disappointed me was if you go to render this, all right? Now, if you render it, it does look pretty good, but sometimes the section caps will disappear. I've noticed that whether you're using the texture one or not. But when you go to render it, it'll do one scale for all sections. You'll get the angles, but they'll all be at the same scale. And just so if you go to render this, you might have to tweak it a little bit to get it to render the way that you want. But other than that, I do like the effect that it gives you. So I hope you get a chance to add those textures for your section caps and incorporate that into your design. If you're interested in those, and certainly you want to hang around to our Q&A section at the end of this webinar. All right, I'm going to close that for right now. And let's see, what do we have that's next? All right. This is one, again, I've done some work for this one. This webinar took me a while to put together. In the back of my mind, I had a few things that I used to show just for fun to people. And up until about 2016, it was back when we used to have the Autodesk Labs. They had a tool that you could bring in called the 2D to 3D tool for Inventor. And unfortunately, that tool's no longer available. But what that tool would allow you to do is if you had orthographic projected views of a component, this tool would allow you to select the views and then help you model the tool. Or you could develop the model from extrusions and intersections. And I started to think, well, what I wanted to share with you was that this process is still available in Inventor, even though we don't have that old 2D to 3D tool. So that's what I want to focus on. And we're going to look at some tips here about copying, pasting from AutoCAD. Hopefully, you know you can do that. And then specifically copy and pasting sketches inside of Inventor using the redefine command and then this interference development technique. So I'm going to start this over in AutoCAD. I've got my AutoCAD application up. And I'm going to start with a regular part. So here's a simple part that I have. I want to show you this with a regular part before I show you how to do the jet. But in this part, I've got my 3 views. Now, in my workflow that I'm going to share with you, it's really important that these views are projected correctly. So not just orthographically, okay? These views are orthographic. But you'll notice my right side and my top view are aligned to this 45-degree line. So if you want to try this workflow, your original 3 views need to be aligned this way so that the side and top views are aligned based on that 45-degree line. Now, with this workflow, I don't need the construction lines. I don't need my dimensions or my hidden lines or my center lines. So I am going to turn those off. All I really care about are the visible edges. So this is like the one time in AutoCAD where I can use that lasso tool. And I can select those 3 views, can right click and select under clipboard copy. So I've got the 3 views copied to the clipboard. Now I'm going to jump over into Inventor, and I'm going to start a new file. So let's jump into standard IPT. I'm going to sketch on my XY plane. That just happens to be the plane that I copied the views from. And if I'm in the sketch, I can right click and select paste. And I'm going to paste this near the corner. Now, the modeler inside of me wants to select this and move it to the actual 0 point. You should do that, but for time's sake, I'm going to skip that step. So I've got my 3 views. I'm going to click Finish Sketch. All right, so here is the first big tip in the things that you didn't know Inventor could do. You know you can make a sketch, you can share a sketch and use it multiple times, but did you know you can duplicate a sketch? So watch this. Over in the browser, I'm going to right-click on Sketch 1 and select Copy. Under my Origin folder, I'm going to pick my XY plane again. I'm going to right-click and select Paste. Now I have Sketch 1 and Sketch 2. They're both on the XY plane. I'm going to do that one more time. I'm going to paste again. This will give me Sketch 3. So I now have 3 sketches all sitting on top of each other. Now I want to redefine 2 of those sketches to put them in the opposite planes. So Sketch 2, here you go. Here's another one. This is just, it's a very rarely used command. It's called redefine. So I want to right click on Sketch 2. I'm going to use redefine. And I want Sketch 2 to be on the YZ plane. It puts it there. And Sketch 3, I'm going to redefine. And I want that to go on the XZ plane. Now, I've distributed the sketches to their specific planes. Now I could begin to develop the part right now. But just to make things a little clear for you, I'm gonna erase some stuff I don't need. So in Sketch 1, all right, in Sketch 1, I don't need this view and I don't need this view. Okay, I just want to clear these up so that you can follow along with the next step. All right. In Sketch 2, I don't need these views. I'll just delete those. And in Sketch 3, I don't need these views, and I'll delete those. So this leaves me my 3 views, and I goofed up there. Apologize. Let me back up for a minute. Let's see, Sketch 3. I want to activate Sketch 3. I should have deleted these guys. Sorry. There we go. So there's my 3 views. Now to develop the part, we'll simply select the extrude command. I'll pick my profile over here, and I'm just going to drag this thing symmetrically way out here. So it obviously crosses the other part. We're going to click apply. Apply is in the dialog boxes. Then I'm going to select extrude again. This time I'm going to select this profile back here and this one right here. And this is going to be an intersect. I can click apply. Then I can select this profile and this one. And that's going to be an intersect as well. I click OK. There is my 3D part developed from the original 3 views that I had in AutoCAD. Now, the thickness of this part is, this is potentially a sheet metal part. You know, we could, I taught sheet metal a couple of weeks ago. It's a great class, but I don't know if you know this, but if you have a part with a common thickness, you can convert it to sheet metal. You can go and define your sheet metal defaults and set your thickness, and then you can develop your flat pattern from that part. So there's the flat pattern developed from 3 views from an original AutoCAD drawing. All right, let me let's go through that one more time. I'm going to try to go through this one pretty quickly, but I have actually, let's do it this way. Let me go to Start panel. I have another drawing here, and this is an old AutoCAD drawing. I will tell you that this AutoCAD drawing is about as old as I've been using AutoCAD. We're talking like Windows 95 is when I drew this the first time. But I did go get it, and I did place these views of this jet, and they are orthographically aligned with that 45-degree element so that my side and top views are aligned as well. And I am going to go to my layer drop down and turn off that construction line. I don't need that. So just like we did before, I'm going to select all of that. I'm going to go to clipboard and copy. And I'm going to jump back over to Inventor. And I'm going to sketch on the XY plane. I'm going to right click and paste my view. And again, I absolutely should move my geometry to 0. It wouldn't take long, just the move command. I could select all my geometry, and I could take that circle, which is why that circle's there, so I can take that and snap it to 0. That way it's exactly where it was inside of the original AutoCAD file. But again, you've seen me do this already. I can right click and copy the sketch, and then I can paste it twice on the XY plane. Paste it once, paste it twice. And then we redefine it. So sketch 2 is redefined to the YZ plane. And sketch 3 is redefined to the XZ plane. And again, just to make things clear, so in this view, I want to see the green. I'm going to call that my elevation. So I'm going to delete these 2 views. I'll finish my sketch. Sketch 2, I want the blue, so I'm just going to delete those 2 views. And then in sketch 3, I want to keep the red. I want to delete those 2 views. If you've ever used the 2D to 3D tool, if you're on the line and you used to use this tool, I'm doing exactly what that tool did. Now, in developing this one, and the reason I'm showing you this, let me pull up my PowerPoint. Ages and ages ago, back in the Windows 95 timeframe, this is one of the first models I ever really rendered. I forgive the crudeness of this aircraft carrier, but we put this aircraft carrier together as a mock-up, and we needed the jets on it. And this is back all the way in 95. This is the way we modeled these jets. We did it with this orthographic development methodology. So, and by the way, back then, all of that was done in AutoCAD with primitive modeling. So, but this is exactly how the 2D to 3D tool works. I'm going to, for time's sake, I'm just going to drag this extrusion way over here. You want to click the apply command. And that's so nice to remember that apply command. I'm going to take that profile. We'll do our first intersection. Click apply. We'll take this profile. We'll do our intersection again. And select OK. So there's our first solid of the fuselage. Now we can go back and make our sketches visible again. That's all we have to do. And then we can do things like the wings. I can extrude the wings, all right, as a new solid body. Multi-solid modeling is an amazing thing. So we're going to use multi-solids to do the wings. We'll apply that. We'll select this wing and tell it needs to intersect that solid right there. We can apply that. We can do the tail. Oops, sorry. We can do the tail as a new solid. I'll apply that. That's going to intersect with this one. Apply that. And then finally, this one is a new solid, was going to meet these 2 as an intersection with this right here. That's That's that extrusion development or the interference development technique of finding a body in space. If you've got 3 views, you can develop a model from 3 views. Now, this is certainly not a perfect model of a jet, but if you remember how I was using it, I was just putting it as a little prop in the background. It's a great way to get like 80% there and then possibly clean this up, add some fillets or develop some different surfaces from this. All right, so there you go. Hopefully, you know, I want you guys to be able to have fun with Inventor, and I want you to be able to develop shapes like this. And seeing a part come together this way, all of a sudden you start to realize, you know, shapes like this are not impossible for me to do. I can absolutely do that. All right, so I'm going to move on. All right, so whether or not you use that technique or not, whether you use that 2D to 3D technique, I hope you saw inside of that the importance of being able to copy paste from AutoCAD, how to duplicate your sketches inside of Inventor, and how to redefine sketches and place them on different planes. Let's look at another workflow. All right, in the next workflow, we're going to develop a part from a picture. If you're into the reverse engineering side of mechanical design, this workflow is really important. But again, whether or not you use this workflow or not, we're going to look at some techniques that you might not know about. So scaling an image, how do you get the image to scale? I'm going to show you how to develop a circle from 3 lines. I'm going to show you that you can pattern work features. And this is where we can copy paste a sketch to multiple sketch planes. And we'll talk about splitting apart with a sketch if you want to do that. Or I've already mentioned using the apply button quite a bit. So let's look at this one. I've got a part here set up. I've got my first sketch already drawn, and in my first sketch I have an image, and I've laid out some groundwork for this serpentine spoke. This is an old wooden form. You can see it's all broken at the bottom, and maybe our goal is to develop a gear from this old image. This is not the greatest image, so forgive me for that, but it is an image of the thing that I wanted to work on. So the first thing I need to do is get a decent circle from this image. So I'm going to do something that a lot of people don't do or they don't know about. I'm going to take a line and I'm going to kind of make this line. See how it hits 2 teeth right there? I'm going to go through this pretty quickly, kind of like a speed run. But I'm going to go over here and try to do the same thing. I'm going to draw a line and pull it down until it kind of hits 2 teeth. And forgive me, I goofed that one up. I want to get that a little closer. And we'll do the same thing down here. I'll draw a line and I'll try to get it to hit a couple of teeth right about there. Okay. Now, with 3 lines, you can develop a circle. It's a very obscure command, but you have a circle tangent, and all you have to do is select your 3 lines, and bang, you're going to get the circle. And this is a great way to develop a circle from an image. Now, I'm not going to delete these lines. I am going to select them, though, and I'm going to make them construction geometry so I can kind of preserve them. Now, real quickly, I'm going to use my offset command. So this is not going to be the most accurate model, but I have a ledge here. I have a ledge down here. I have a ledge right about here, and you can see how bad this drawing is as I come through, and the center hole is going to be right there. So if you ever are going to do this, there's much better ways to get your image. If you're scanning, if you're doing photogrammetry, there's better ways to get a good head-on image of a part, but that would be for another time in another webinar. I'm going to finish my sketch though, and I want to start developing the spoke. That's the fun part of this, is developing the spoke. So I'm going to put a work plane at the end of the spline, right? Got a work plane there. Now here's the neat tip. You can pattern work features. Watch this. I can click a rectangular pattern. I want to pattern this work plane, and I want it to follow this line. And just like a distributed pattern along a path, I'm going to pick curve length. I want 10 work planes, and I want them to follow direction 1. I'm surprised at how many people do not know that you can pattern work planes. I'm going to circle back to this in a minute and show you some other examples of this, but patterning work planes is a very, very good way to develop shape like this lofted spoke. Let me turn back on my sketch. Now, I don't need all of these planes, but I wanted to distribute them. So for instance, I need these 2 planes. I don't need this one. I need that one. So I'm going to skip it. I don't need these 3. I want this one. I don't want that one. And the work planes, even though they're put in by a pattern, you can right click and make individual ones disappear. So you can still control the visibility like a normal work plane. Now, I need a work point where this plane intersects that spline. And then I can sketch on this plane. Here's one. You know how Inventor does what it just did, how it always orthographically looks at the sketch plane? F5 is previous view. If you didn't know that, write that down. F5 for previous view. It's a function key. So I'm sketching here. I want to use project geometry to get that point in my sketch, and I'm going to draw an ellipse. We'll draw our ellipse over here. We'll come up right about there. I'm doing this rather roughly here, but that's what I think that spoke looks like right there. Now here we go. I showed you this earlier. I'm going to finish my sketch. Now watch this. I'm going to copy that sketch. I'm going to select this work plane, right click and select paste. I can select this work plane and do a Control V. I can do the same thing here, Control V, and here. So I can copy that sketch to those other work planes. Now we can resize this particular ellipse. And this one right here is going to get a little bit bigger because of that flare. It flares at the end. And then over here, just for time's sake, I'm just going to flare this last one. I'll make it flare out a little bit. So there we go. We used that copy paste sketch from the previous example here. Now I can start my loft command, and I can go from this ellipse to this ellipse, and then to this one, and this one, and this one. There's actually a loft called a center line loft. This is a very rarely used one, but if I pick the center line, it's going to flow right through that area. And I think we got that pretty close. We're not going to get it perfect going through it this fast, but we're pretty close here, so I'll click OK. And we've got that lofted shape. Now I'm going to take the visibility off of these work planes. I don't need that anymore. I'm going to right click, remove the visibility. And then let's do some simple modeling real quick. Let's take the center hub. We'll go up 1 inch. So 1 inch total. We'll click apply. We'll take this hub and this hub, and we'll drag the arrow down. And I'm just going to visualize these the best I can. Apply. And we'll take that and this. We'll drag that down just a little bit. We'll click apply. And then I'll take this notch and I'm going to cut that through all. So that'll be 1 tooth. So there we go. Now I can real quickly, I can do a circular pattern of the serpentine spoke. And this is a very old model. So I say old school. There's only 5 spokes. Kind of neat. And we'll do another circular pattern of the tooth gap. And there's 66 teeth in this. I know this from just practicing this. And there we go. So there is that gear developed from the picture. If I take the original sketch and hide that, we could clean this up. Let's add some color. You know, you can select faces. I think most people know this. You can select faces holding the control button down. and then we can add a color to those selected faces. I like this color chestnut. It's kind of like a chocolate brown color. I just like that color. And then for time's sake, I just want to go back and bring the sketch back and reiterate what we did. We developed this part, all right, completely from an original sketch. Now, the one thing I didn't show you, and I apologize, and this is my fault, I kind of goofed this up, but if I go back to my original sketch, you notice I did this without dimensions. Watch this. If I dimension this circle, I should have done this before I did my modeling, but I'm going to just go to 12. The first dimension will scale your sketch. So when I click Finish Sketch and I update, the part should update to suit. Now, the only thing that didn't update was the size of my spokes, but I could go back and modify that. But that first dimension scales the sketch. I should have done that early on when I made the circle. That's my mistake, I forgot that. But you've seen the result. That first dimension scales the sketch, and then everything else kind of, not parametrically, but visually updated to suit. So there you go. Now, if I had plenty of time, I could come back and get my fillets in place and really make this thing a lot nicer than it was, but we developed that entire part from a picture using some very nice techniques. All right, let's see where I'm at here time-wise. I mentioned patterning work features and some of the things you can do with this. Again, people just, they don't understand some of the possibilities. So I'm going to open up my skull, and the skull itself is a whole nother thing. I did the skull with photogrammetry. So that was a Halloween decoration, and I took a bunch of pictures, and I brought that through Fusion and the mesh, and I converted it to solid. That's a whole nother webinar as to how I got the skull, but I patterned the set of work planes to go through here. And then I used the work planes to develop 3D sketches of the topology of that complex object. So patterning the work planes allowed me to do this. One of the results here would be the fact that I could now do a new drawing. And I could bring in the skull. I'm just going to go to this side view here. Let me make this a little bit bigger. I don't want to display tangent lines here, so I'm going to click OK. So finally, I should get that. And then what I can do in the drawing is I can go in and find that 3D sketch and say include it. So I can see those topology lines in the drawing. And of course, if I double click my view, I could change it to the right side, click OK. And I could see the topology lines of the skull. And I don't have to shade it. We could just see the topology lines in our drawing view. That's an example of, again, developing those topology lines and getting those things inside of Inventor. I've seen this technique done developing substations and doing the topology of a terrain surface that we get from Civil 3D, and needing to get that stuff into Inventor is kind of important. So I'm going to close that out. Another example is here. Here I patterned I put a point at 0, 0, and I did a 3D pattern. I patterned 5 inches over and 5 inches up, and 5 inches on the Z. So I made a pattern of points, and then I used the pattern of points to do a 3D sketch. And so all I'm doing, if you ever do 3D sketches, you're just playing connect the dots. So I'm going from point to point to point to point, and I'm kind of doing a pipe run through 3D on a grid of points. And then I just modeled the pipe in accordance with the path that I defined. So not necessarily, I don't know that I would use this in production, but it just goes to show that there is a benefit to patterning work features. All right, let's do another model real quick. Back in my PowerPoint presentation, The next thing I want to look at is developing complex shapes. And like, this sounds silly, but hopefully you guys recognize this as a mouse, like an old Microsoft mouse. I promise when I model mine, I'm not going to model one with a little roller ball at the bottom of it. I promise I won't do that. But you might ask yourself, with these kind of crazy shapes, how would you develop this? I mentioned earlier our advanced class, and in our advanced class, I taught it a few months ago, and there's these new chapters for surface modeling. And a lot of people, they've been using Inventor for years, and they've never touched surface modeling. So I want to go through and model this mouse real quick. And in doing so, I'm going to use some surface techniques. I'm also going to do another sketching technique where there's a gesture to add a line between two circles. So let's hop over here to my mouse example. And I'm running out of time here, so I want to finish this up pretty quick. So I'm going to edit my sketch. And I need to draw a line between the two circles. So here's that gesture I mentioned earlier. I'm going to hold my cursor on the circle, left click and drag. That'll give you the tangent when you leave. And then you can come over here and find the circle here, tangent to where you let go. And you get that line between two circles without having to add constraints. For time's sake, I'm just going to draw this arc, and I'm going to manually add my constraints here. I want that to be tangent. I want this to be tangent. When I trim, when you start the trim command to get rid of all this interior stuff, just left click and drag. You'll see a little line that appears, and anything it touches, it'll get rid of. Now I'm going to finish my sketch. There's my little bean shape. And I'm going to use a tool called a surface patch. This will take any profile and turn it into a single surface. There we go. Surface modeling has been in Inventor since the very beginning of Inventor. So for instance, a ruled surface. This allows me to, add an angular surface coming off of that one. I'm going to go about 20 degrees out on that. Then I can add my patch to the top edge here, and then I can use the tangent option to make this puff up like a little balloon. And that gives me that general mouse shape that I'm looking for. These three surfaces contain a volume, and that's where the sculpt command comes in. You can click these three surfaces and turn that into a solid body. I have another sketch here. I put this sketch out here just to make this a little easier for me. But I could come in and just make sure my sketch is completely inside the part. And I could use the tool, the emboss tool, to bring this down, and I want to emboss it. And the color swatch on the emboss, if I wanted to come down and use I like rubber black. That's the black that I tend to use. And how about 0.01? I can share that sketch. I'll extrude this shape downwards into the part. Do that, a cut there will do. We'll get rid of the visibility there, and we'll sketch. Got to make that little wheel. So project geometry on that face, and then we'll do a little offset. And I'll draw a line midpoint to midpoint. We'll do a revolve, just R for revolve around that axis. And I'll put a little color onto this as well. That face right there, will give it a gray face. So I'm not going to put a roller ball on the bottom. I did use mice that had roller balls on the bottom way back when, but there you go. That's my take on how to generate some simple, some complex shape using the simple surface commands. And again, I've had people use Inventor for years, and they come to the advanced class We show them a few surface tools and you see the light bulb go off. Oh, that's how you make those shapes. That's how you do that. So it's very, very useful. Now, quickly, guys, we've come kind of near the end of our time together. I hope you found some techniques in what I shared with you. I do have on my YouTube channel, 3D All Day Every Day is the original 10 things you didn't know Inventor could do. That's the video that kind of started this web series. If you haven't watched that yet, my YouTube channel is 3D All Day Every Day. There's 10 pretty simple techniques up there. And certainly, I do want to thank all of you for just making the time to pop in and to participate in this. Of course, if any of these techniques have spawned an idea and you need to talk with us about potentially taking these ideas and moving them forward in your workflows, you know, we're here. I'm not just a teacher, I'm a consultant. I can come in and work with customers, or I'm sure you have consultants in your local area that would be glad to answer the questions that some of these techniques might have brought up and some of the possibilities that are dawning on you now. So I want to thank you guys, and at this point, I want to open it up for questions.